Get ready, people, as we are gonna start the session now. Do you know half of their lives humans work in a cognitive slumber? Well, a part of it owes when we don't have an idea to where we are headed. Well, antidote to unclarity is having right mentors and the right guidance. Hello everyone and welcome to DSA Carnival 2.0 opening session on career guidance and basics of DSA. Prior to beginning with the session, I might want to enlighten you regarding DSA Carnival 2.0. It will be a 10 days course and will be streamed on our YouTube channel. After the completion of the course, students will be provided with some quizzes to test their understanding. Well, that is not it. We have a lots of prizes in store for all the participants. So just gear up and watch out this 10 days exciting journey. I would first like to thank Geeks4Geeks to sponsor the event. Moving further, we are having two amazing speakers for today, Mr. Sandeep Jain and Mr. Soham Mukherjee. It's a great pleasure for me to introduce them. So first, from our speakers panel is an IIT Roorkee alumnus and founder of Geeks for Geeks. His love for the problem solving is what sets him apart. Besides creating a giant organization, Geeks for Geeks, he has worked with DE Shaw and Co. as a software developer and JIIT Noida as an assistant professor. A gem of his own kind, Mr. Sandeep Jain. He will unfurl this great journey of knowledge and coding under the flag of DSA Carnival 2.0. Having him as our speaker is a real honor for us. Over to you, sir.
Thanks, Mansi, for the introduction. And thanks for the great video being played at the beginning. First of all, I would like to thank all the organizers here for organizing such a grand event. And I strongly feel like events are like this are going to be super useful and much needed events in India, especially. I am going to talk about DSA in this DSA event, and DSA is something which is very close to my heart. I have been like in this industry from a long time. And guys, I've seen this engineering education, this DSA, interview preparation, competitive programming very closely from so many years. Now, I did my engineering in 2004, and DSA is one topic which has always been there, like the most important thing when it comes to interview preparation or when it comes to getting a job. And in India, that's what most of us do engineering for. We do engineering to get a job. That's our primary target most of the time. So there are many technologies which come and go. When I was doing engineering in 2004, people were talking about web development, JavaScript. Those were new things, relatively new things at that time. And there was nothing like Android development or React language and all these Django and all these web development platforms. And DSA was still there. When it was about interview preparation or when it was about cracking interviews, it was mostly about problem solving and which requires knowledge of DSA. And I have seen it from so many years. Even now, when you talk about most of the companies, I go through lots of interview experiences which are published on Geeks for Geeks. Most of the companies, 90% of the time, ask DSA only, problem solving only. And many people, with the rise of technologies like machine learning, data science, feel like DSA is going to go away. But guys, if you ask me, it's not going to go away for at least 3-4 years. That's what I can confidently say. Because top tech giants like Google, Facebook, especially Google, they hire only through DSA. They take DSA or problem solving exams only for freshers to hire. So, and if Google changes it after 1 year, then other companies are going to take a lot more time to change their hiring process, to follow the process. So it's not going to go away, guys. It's going to be here, and it's the thing which is required for software development jobs or interview preparation jobs. And not only for interview preparation, when you are good at DSA, when you are good at problem solving, or you are a good competitive programmer, you become a superstar in your college. That's how a DSA and competitive programming is these days. In our days, the academically excellent people, they were superstars in colleges, those who were having highest grades. But those days are gone. These days, the people who do really well in competitive programming contests, who are very good at problem solving, most of the students go with them. They go to them and ask questions and discuss problems. They are the superstars. And whatever path you wish to follow in your life, whether you want to be a top competitive programmer, if you enjoy that game based coding where you are participating in a contest with multiple other students, or you want to be a quality coder or a person who likes writing beautiful code, who sees coding as an art, or you want to be open source developer or anything you want to do, Android developer, full stack developer, DS is something which is very very much required for all these things. Whatever you do, you need to have very very good knowledge of DSA. That's the bottom thing, or that's the pillar of all these things. Whether you want to be a quality software developer or a top competitive programmer, you must know DSA really well. So how do we learn DSA? Or the most important thing is about job. If you want to get a job, then DSA is definitely required. Now the question arises: how do we learn DSA? What should be the roadmap to learn DSA? That's what I'm going to talk about in the rest of my talk. So guys, the first thing that you need to know, that you need to learn before you begin DSA is a programming language. You need to know a programming language. Now the question arises: which programming language I should pick? So there are multiple programming languages, and out of these, the three most popular languages are Python, C++, and Java. Now, out of these three, I would strongly recommend to go with either C++ or Java. Why not Python? Because in Python, you don't learn the core basics many times. You have things built in and which might impact your learning. Also, it's a language which is built for ease of coding, quickly learning coding and easily writing the code. It's not a language which has all the data structures implemented. For example, the self-balancing binary search tree, which is implemented in C++ STL library and Java collections, is not there in Python. Now, out of these two languages, C++ and Java, guys, I would say it's up to your choice, whatever you do. And you can pick Python also, because Python is growing really good and many students and many people follow Python. And see, it's all about just a language is just a tool. You learn a tool to communicate with the computer and then you communicate, right? So the choice of a language does not matter very very much, but for freshers the most used languages are C++ or Java most of the time. Now the question arises: which language out of these two I should pick, C++ or Java? So it depends upon you what type of programmer you are. C++, when you compile and run code, you quickly get a response, right? You get a response whether it has error or what test case it is failing for. That response comes much faster when you compare C++ with Java. In Java, it takes some time to compile, run, and then show you something on the screen. That's the advantage of C++. So if you talk about advantage, if you don't have much patience and if you want to quickly see your output, you would prefer C++. Now the bad thing about C++ and the good thing about Java is C++ allows you to do bad programming. For example, if you write in if condition a equal to b, right, which is a bad programming, right? Instead of writing a condition, you are assigning a value to a variable. Now, this is allowed in C++, but not allowed in Java. In Java, it will give you error. So this kind of bad programming can cause so many hours sometimes. You forgot to write an equal, you did not get any error. Your code compiled and ran. And now you are struggling to figure out what happened, what went wrong. And there are multiple options many times to do a single thing. For example, if you want to pass a variable by reference, you can either use references or pointers. So in Java, there is only single thing, reference, and pointers cause a lot of problems. The most difficult error that we get is segmentation fault in C++. That's really difficult to many times debug when you have a long written code. In Java, you have only references, and and there are many restrictions on the programmer, many good restrictions, many types of syntaxes like assigning a variable in if condition is not allowed in Java. So these are good things about Java. So if you are someone who wants to write quality code, don't and want to follow certain rules when you are programming, Java would be a preferred language. And if you talk about industry, Java is still one of the most used languages. When you compare with C++, it's much more used. Now, Python is slowly picking up, but Java is still out of these three the most used programming language in industry. So that's all about languages. If you are patient coder and if you wish to write logical error free code or want to follow the rules, Java would be a good language. And if you want to quickly see the output, and if you are confident that you will not make language specific errors and you will learn language super well, then C++ is something which you can prefer. And language is just a tool, guys. I will again repeat this thing. You can learn any programming language within certain months. And most of the top tech giants, they don't care about the programming language, They only care about your problem solving skills. When I joined a software company, a top tech software company, they did a training for us for a month and they taught us everything, right? So we were tested mainly for our problem solving skills, and other things are taught as a part of training. So once you pick a programming language, once you have picked a programming language, then you need to learn data structures and algorithms step by step. So how do we learn all these data structures and algorithms? The first thing is there are many standard data structures. There is this array data structure, linked list, tree, cell balancing binary search tree. Then you have hashing. And hashing, guys, is the most underrated data structure in academics. When it comes to industry, it's used a lot compared to other data structures. I would say after arrays, that's the most used data structure, hash tables. So you learn these basic data structures one by one, and when I say you learn, you actually need to understand their concepts. You need to implement these data structures yourself at least once. For example, if we talk about stack and queue data structures, you learn a programming language, and in that programming language, using the language constructs, implement these data structures yourself. Implement a stack yourself using array and using linked list. Implement queue yourself, and similarly learn algorithms basics, learn binary search, learn all sorting algorithms. There are multiple sorting algorithms and they all have their own advantages in certain situations, right? Certain algorithms work really well when your data is uniformly distributed. Certain algorithms work really when you have a small array. Some certain sorting algorithm works really well when you have almost sorted array. So many sorting algorithms for different purposes. So learn all these sorting algorithms and implement these sorting algorithms yourself once. Once you understand basic data structures and algorithms, and once you have implemented these basic data structures and algorithms yourself in a programming language like C++ or Java or Python, then what you do is you learn libraries of these languages. Now, when we talk about libraries in C++, we have STL, standard template library. In Java, we have collections. So these libraries provide you ready-made implementation of standard data structures and algorithms. For example, there is ready-made implementation of queue data structure, ready-made implementation of linked list data structure, ready-made implementation of cell balancing binary search tree. In C++, for cell balancing binary search tree, you have set and map. In Java, you have tree set and tree map. There is ready-made implementation of dynamic sized arrays. You have vector in C++, you have array list in Java. So learn these standard template library if you are programming in C++. If you're programming in Java, then learn these Java collections. So Java collections contains huge library. There are lots of library which are required for synchronization and other stuff. Those libraries typically you do not need for competitive programming or interview preparation. You can purely focus on single threaded related libraries and which are basic data structure implementations and basic algorithm implementation. So apart from data structures, these libraries also have implementations of algorithms like binary search is implemented, sort is implemented, and sort is a general purpose function which works typically well for all kind of input arrays. So so these steps are: first learn a programming language, then learn basic data structures and algorithms, implement these basic data structure and algorithms yourself after learning, then learn libraries, learn STL in C++ and Java collections in Java. These libraries have ready-made implementation. Learn these really well. And after learning all these, you need to learn where to apply which data structure. And that is something actually you will learn as part of learning basic data structures and algorithms. You need to really know well where to apply which data structure. For example, when you talk about hashing, it's such a beautiful data structure, hash table rather. It allows you to do search, insert, and delete in big O of one time, right? On average. So you have a data, you want to search an item in this, you want to delete an item in this, you want to insert an item, or you want to do a subset of these three operations, then all these operations are big O of 1 in hashing. That's the great thing about hash data structure or hash table data structure. So learn these data structures, learn their usage. For example, if you talk about arrays, the best thing about arrays is random access. You can access ith item in a sequence in big O of 1 time, which is not there in hashing, right? If you want to access ith item in hashing, you will have to traverse one by one in hash table, right? Or you will have to maintain a separate data structure to maintain the orders. And arrays have random access, they have cache friendliness. All the items are stored at one place in memory, so you can quickly your data is quickly accessible. There's locality of reference concept in caching that works really well in case of arrays. So you need to know all these things about all the data structures, right? So when you talk about self-balancing binary search tree, for example, it allows you to do search, insert, delete in moderate time. In arrays, it's slow. Search is binary. If you have sorted data, then login. Otherwise, it's slow. Insert and delete are also slow. Hashing is super fast, big O of 1. Self-balancing binary search tree is a moderate data structure. It allows you to do search, insert, delete in moderate time. Better than arrays and worse than hashing. But the best part about self-balancing binary search tree is it allows you to do other operations when you compare it with hashing. It allows you to access the data in sorted form, sorted manner. It allows you to find floor of a number, a number which is just smaller than the given number or equal to given number. It allows you to find ceiling of a given number in big O of login time. So all these kind of operations are allowed with self-balancing binary search tree and we go up one search, insert, delete, and hashing. So learn these things really, really well. Learn where to apply binary search. Learn where to apply dynamic programming. Learn where to apply greedy algorithm. And there is no formula as such, but there are some basic concepts as I discussed: search, insert, delete operations. When you have sorted data, then you apply binary search. When you have overlapping some problems, then you apply dynamic programming. So once you learn all these basic concepts, where is what applied, right? Then you do a lot of practice. You need to do solve a lot of problems, lot of algorithm problems, and you can go to any practice platform. For example, you can go to practice.geeksforgeeks.org. You can pick a category, right? Decide a category according to your level. For example, if you pick medium initially and you are not able to solve medium level problems, then change your category to a lower level, right? And if you are able to solve medium problems, then change your category to a higher level. So now you've understood data structures. Now you started practicing problems, right? So when you are practicing problems, it's okay to see the solution sometimes, right? Just be honest with yourself, right? That you are learning day by day, you are improving yourself day by day. And don't get depressed or demotivated if somebody else is getting better rating than you on competitive programming platforms. Guys, there are different people have different learning curves, and somebody might be a better gamer programmer and you might be a better artistic kind of programmer. Some you might be a programmer who writes very clean code. And when you talk about software development, they need a quick problem solver, and at the same time, they need people who write clean code, beautiful code with a lot of comments, with proper breaking of in terms of functions and proper variable names and minimum number of variables, no extra variables, right? So just pick what kind of programmer you are, right? And everybody has a different learning curve. What might happen is you might initially take some time, but later you might become a faster solver than the other person, right? So don't compare yourself with others, and just make sure that you are an improved version of yourself daily in terms of coding. You're improving day by day, right? You're solving more and more problems. And if you are getting stuck on a day, like I solved the problem whole day, I could not come up with a solution, my whole day got wasted. Don't feel that way, because you must have tried, thought of different approaches, right? And you must have rejected them. This is not applying here, this is not applying here. This is also a very important learning. And form groups. Fortunately, these days you have online groups, and you have YouTubers who are making videos. There are comments you can discuss there. They have groups where you can ask questions, right? So form groups, And if you are stuck in a problem, or if you don't want to look at the solution, discuss with the people who are better coders within you, or maybe somebody who is at your same level, right? So form groups and discuss these problems with them. That also is very important part of your learning, right? So I'll repeat what steps I have discussed so far. Learn a programming language, learn data structures and algorithms, basics of data structures and algorithms, implement all standard data structures and algorithms yourself, right? When I say data structure standard, I mean all the basic data structures, linked list, queue, stack, cell balancing, binary search tree, and everything including hashing. And implementing standard dynamic programming problems also, longest common subsequence, longest increasing subsequence. Learn, implement all these yourself, right? Don't look at the solution. Look, you might want to, and obviously you would like to have a look at the algorithm, right? Then otherwise how will you learn, right? So learn these, implement these basic data structure algorithms. Once you have implemented, then learn the libraries which have ready-made solutions. Don't learn the libraries before implementing yourself. Learn the libraries, then start solving the problems. Pick a difficulty level. Once you have picked a difficulty level, then you would like to change it if you are facing problems, right? If you are able to solve all the problems, also then you would like to change it. So change your difficulty level time to time. Make groups, discuss with people. Don't get demotivated if somebody else is solving faster. And if you're preparing for interviews, then again don't get demotivated if somebody else in your class or in your batch is getting selected. Guys, there are lots of success stories on social media. You never know how many times those people were rejected before they actually got selected, right? So rejections are part of the journey. You get rejected many times, and that's how you learn. And I would strongly recommend, guys, if you are in third year or final year, then with practice and learning, you need to appear in interviews also. Don't feel like this company is offering me only 5,000 rupees stipend, or this company is small, this is startup, why should I appear in this company's interview? Appear in every interview wherever you get an opportunity, because when you appear in interviews, you learn different things, right? It's not only about learning data structures, solving problems. You also need to learn what happens with you when you go to an interview environment, when you are asked question in an interview environment, and the outcome of this question decides your career. So you also need to learn that, because earlier you do it, better for you. We become top coders, we become super good coders, but even then we get rejected. Even then we get rejected because of behavioral issues, because we never appeared in interviews before, and we get sometimes we get nervous, sometimes we get some other problems, right? Sometimes the interview where it is happening, you're not familiar with the environment. Sometimes an interviewer might ask you question on whiteboard, right? And you never done coding problem on whiteboard, right? So appear in interviews. That's very, very important. Try to appear in as many interviews as possible before you go for actually big day interview where you want to get selected. And even if you rejected in that big day interview, more big days would come, right? So it's part of the journey. You get rejected and then you get selected, right? So appear in interviews as well. That's very, very important as part of the learning. When you are solving a problems, make sure that you are applying also by appearing in interviews. And if you are not getting chance to appear in interviews, which is very possible that not many interviews happen daily, right? So try to do mock interviews with your seniors. Try to request a senior, or try to request somebody who's your elder brother, somebody who's working in a software company, to take your interview, do a mock interview, right? So that if you are not getting a chance for an actual interview, participate in a mock interview, right? So once you have appeared in interviews, once you have solved a lot of problems, once you have and when you talk about solving problems, guys, it's all probability. So there is no limit on solving the number of problems. If I tell you that, okay, so you solve these 500 problems, you will crack interviews. I mean, don't believe in that, right? If anybody says you this, if anybody says you this, join this course, attend my classes, you will get a job in 6 months. It's never like this, guys. It's all about probability, right? More problems you solve, more probability of you getting selected, right? If you have solved 500 600 problems, the probability might be zero point 0.5. If you solve 1,000 problems, it might become zero point 0.7, and then 5,000 problems might become zero point 0.9. But again, it's all probability. Even then you might get rejected. You never know what happens on the day of interview, right? You might get nervous. The interview is not in a mood. He asks totally a different question which you've never studied, even if you solved 5,000 questions, right? So it's all probability, no confirmation ever, and don't demotivate. Don't feel demotivated if you get rejected, guys. Again, it's part of the journey. Even if you have solved 5,000 questions, you might get demotivated. You might get rejected, right? Be prepared for that as well. So I think that is all from my side. Yash, Mansi, I'll take a leave from here, and I think we can now invite the other speaker. And if you have any question, Mansi, if you want me to discuss anything else, I am open for that.
Thank you, sir, for this amazing career guidance. Your journey was very exciting and inspired all of us today in many ways. We are grateful for the time and effort you took to share your thoughts and experiences with us. Thank you again for your contribution.
Thank you, Mansi. Thank you, everyone, for being a great listener. I hope this must have helped you definitely, and looking forward for improved coders, and really hope, guys, that you do really well in your careers. Thank you, Mansi. Thank you, everyone.
Thank you. Now, let us introduce you to our second speaker for today. From being an educator at Geeks for Geeks to interning at CodeChef and DE Shaw, and currently working as an SDE at Google, he has made his mark at every place with his top-notch skills. He has taught thousands of students about DSA, and today he will be teaching you all the micro and macro mantras of being a successful programmer. Let's welcome Mr. Soham Mukherjee. We all are super excited to have you here. Over to you, sir.
Thanks, Mansi. Thanks for the kind introduction. Hi everyone, can you guys hear me? My current went away, so sorry about that. Let me know. Can you guys hear me?
Yes, sir, you're audible now.
I think yes, I can see myself. Yes. I'm sorry about that. The weather in Hyderabad is not at all good, so that's why it's raining for like 2 3 days, and that's why they've just cut off the current. Uh, but yeah, like I might be lagging a bit. I'm working from mobile hotspot because again, like without current, I don't have access to Wi-Fi. But yeah, like thanks Mansi for the kind introduction, and I'll start by like I was actually listening to what Sandeep has said, and I truly like believe in what he has said because I'm actually a but before that, like let me know if you guys can hear me well, because if there is a lag in my audio, I think that should not be a great experience for you. So are you guys can you guys hear me properly? Can someone write in the chat if you guys can hear me properly? Because I believe like hearing me is better than like yes, you're well audible. Awesome. Thank you, Shivank and Hitesh. So yep, let me just quickly share my journey. Like I'll not waste a lot of time, but so what he said right about rejections. In fact, I also faced a lot of rejections during my time. So I basically initially when I started, like I D Shaw visited our campus, and it was kind of the first company that was coming to our campus, and I got there. So I didn't actually see a lot of rejection during my internship phase, right? So I interned at D Shaw, and after that, I got an opportunity to like interview for Google, right? So Google is, I believe, like everyone's dream company, and most of you have heard your dream company is also Google, and it was mine as well, without like any doubt. Google was my dream company as well. So I got an interview with Google, and I was very excited about it. So I used to do a lot of competitive programming. Definitely, like I believed in my programming skills. So what happened was, the interviewer told me that, hey, your interviews will be scheduled like on these and these dates. And I was a bit overconfident, right? Because I was a good competitive programmer at that time. So I was a bit overconfident about my skills, that hey, I have done competitive programming. I cracked the first company that came to our college, so definitely I'm good enough for Google, right? So I went without any preparation, and that was the worst thing that I'd ever done. So I went without any preparation, and that was on site, like in 2019. The interviews were on site, right? So I went to their on site. After 3 rounds, generally Google has 5 rounds of interview. After 3 rounds, they rejected me because, again, like, it's not that I wasn't able to solve the problems, but how I solved the problems were not that good. By that I mean, I didn't write a very good code, or I took some time, like, I didn't clear the requirements with the interviewer, right? So whenever you are sitting for an interview, it's very important that you should always clear your requirements from the interviewer. Like, let's say I'm asking you a question, right? I might not give you all the information, right? Because that's what I want you to do. I want you to ask me questions, so that you ask me those questions, that you clear the requirements by yourself, right? I didn't do that, so that actually wasted a lot of time. And for that reason, yep, I was rejected in the third round, and I was not allowed to sit for the next 2 rounds. So that was a very disheartening moment for me. But after that, I took that as a very good, like, I took that as a learning. Instead of like getting demotivated, I took that as a learning, that hey, it's okay. Like, I understand Google is my dream company, but my life doesn't end here, right? I do have a people around me who are sitting for other companies as well. But for most of people as well, this is not the case. Like, they might be, this is the first company they are sitting for, or this is the third company they are sitting for, and they're still getting rejected by every company. So just to share some insights, learn from every interview. It doesn't matter if you get selected or rejected, but there is a learning that you can take away, right? So make sure that in the next interview you do not make those same mistakes again. So have some learning from every interview, right? And yes, with that, yes, my current is back. So yes, with that, yes, code quality is important. And you don't have to be sorry. I'm finally in Google, so I did get an offer from Google after like 1 year. I was working with Code Nation. Like, after that, I cleared multiple companies. I cleared Code Nation, I cleared Shopee Singapore, I cleared Reputer Robotics Japan. But then I also cleared like Tower Research. I've cleared Google and a lot of companies, right? So, but again, like, I believe that moment, I needed that moment, right? I needed that setback, because that setback had made me much better. Like, at least right now I'm not confident about any interview. Before every interview, I prepare myself well. I give a lot of time around preparation, and after that only I sit for the interviews, and I'm never confident that I can crack it easily. Rather, I try to be very, like, I try to calm myself down and say that, hey, I might be rejected as well. And I do have that, like, I do consider that option as well, right? Definitely, if you are getting rejected, that's not your end. You will get a lot of opportunities in your life. So don't think that's the end, and always like keep some learning from every interview that you sit on, right? So with that, we can start with today's session. And yeah, like, feel free to ask me if you have any questions. I have the chat open by my side. And sometimes, like, just to like tell you guys, sometimes I might look to the side, and that is not because I'm not listening to you guys, but it's because I'm seeing the chat, like whatever you are typing in. Because I cannot see it on my screen. I'll be sharing my screen to teach you something. So yeah, like, just feel free to ask me any questions, and I'll be definitely reading them out, right? So with that, I'll be sharing my screen. I hope that it gets shared, entire screen. And here we go. Yep. All right. Cool. And if you guys face any problem during the entire session, just let me know. I'll be like, trying to help you out, right? So now coming to interview preparation, or coming to DSA in general, right? So as Sandeep said, has already said, and as you might already know, you might have read about people, about like stories. What a very important part of any interview is DSA, right? What is DSA? DSA is data structures and algorithms. Nice wallpaper. It's not a wallpaper, it's the default theme. uh, how did you get selected for research and development intern position? What was the requirement? Research and development, I am not into research and development, I am more into development. uh, for development, it is mostly about cracking interviews, and there are DSA questions generally for freshers. So yeah, like that, we'll talk about that only, right? So DSA is data structures and algorithms, right? Now, what exactly is data structures and algorithms? So let's write it down. It's broken down into two parts: data structures, although they are said together, but it's actually two things, right? Data structures and algorithms. What is data structure? Data structure is, there are various data stores, right? Data structure is a data store, how you store the data in memory, right? So that is a data structure. Why is data structure important? So different data structure provide you with different benefits. Like for example, let's say you are you must have used Google search, right? Or let's say you are using some IDE where you like write your code. So when you're using an IDE, you might have seen that when you type something, it is auto completing, or it is giving you a list of suggestions. That let's say you have written if, and it will give you suggestions like for or something like that, right? So this search type ahead, this is called search type ahead problem. So this search type ahead, how is it implemented, right? Or so there is a special data structure called a try, that is basically helping you search all these things in an optimal fashion, right? So given a string, so what is the problem that we are solving? Like when we are talking about search type ahead, when we talk about search type ahead, right? So what is search type ahead again? Like you type some characters, right? So let's say you type, let's say so, right? And it will give you a list of suggestions. Like you haven't typed at all, but it will tell you so can be sohm, soham, right? Or so can be uh, somewhere, right? So these are possible, there are multiple other possibilities, right? So given some given some set of characters, what are the words that will be completed by or the whose initial part is this set of characters, right? So this part, this initial set of characters is called a prefix of a string, right? So given a prefix of a string, how many words matches has that string as the prefix, right? So that's basically the problem. So that is solved optimally using a data structure called a try, right? Again, like we'll not get into details about them, those are like pretty advanced concepts, and we'll mostly focus on the basics, right? We'll just stay on the basics just to give an example that why is data structures important. So there would have been multiple solutions, like you could have used something like an array, you could have used a tree, you could have used all the tries a tree, but you could have used some other form of tree, or you could have used maybe a linked list or something like that, right? So all these are data structures, and out of them you saw that try is actually giving you advantage when it comes when it comes to the problem of searching with respect to a prefix, right? So that's why you're using a try. So different data structures provide you with different advantages, and we'll see a few of them definitely. But that's why we have multiple data structures, right? So data structures are data stores where you store the data in memory, and the way you store the data, that is data structure, right? Just to give an example, array is stored how? Like I'm not sure if you know about arrays, but array is a linear data structure. Like let's say you have n elements, right? You have n integers, you want to store them, so you store them like this: 2, 3, 4, 5, 6, like this. This is how. And what is an array can you name some good resource for playlist for coordination DBMS OS system design? uh, DBMS OS system design. What I did was I mostly studied DBMS OS from like my school, like my college books, right? Because they were pretty good. The books were pretty good. They had a lot of knowledge, and definitely like exploring the important parts on the internet as well, like reading about them and understanding them better. Regarding system design, like there is a lot of content. Like just search for system design content, and you will get a lot of content, lot of articles, lot of videos these days online. Just like go through them and understand. And also there is like you can get some interview experiences as well, where people have written some experiences about how to solve some system design questions. So definitely look at them, right? So yes, coming to this, like this is how an array looks like. It is a linear data store where you, if you want to store a collection of elements, you can store them in an array. What is the, how is the element stored in memory? Like if we think about how is the data stored in memory, in array, the elements are stored in continuous blocks of memory, right? In continuous blocks of memory, that means each integer in C++, I'm talking, let's take the example of C++. Each integer is 4 bytes. It takes 4 bytes of memory, right? So definitely to store them, it will take some memory, like it will take some space. So each integer, to store each integer, it will take 4 bytes of memory. So let's say this, in the memory location, in your computer's memory location, let's say at location 1000, 2 is stored, right? So 3 will be stored in a continuous segment, that is at location 1004. Why 1004? Because 1000 to 1003 will be taken for storing 2, because it will take 4 bytes, right? So 4 will be stored at location 1008, 1016, 1012 and 1016, right? So this is where, how they will be stored. They will be stored in continuous segments of memory, right? Now there is a problem with this. What is the problem here? So in many cases you will be using array, right? But the problem with array is that it, you lose a lot of flexibility. What do I mean by this? If you, let's say you have to delete 4, you have to do a lot of things. What you have to do when you delete 4, you have to bring 5 6 before 4. So 2 3, and now 5 will come in place of 4 and 6 will come in place of 5. So if you see the new locations, 1000, 1004, 1008 and 1012, so you have to again like move all the elements that are occurring after 4 and by one place to the left hand side, right? So you have to do a lot of work. Also it might be happening that actually you are storing a very big array, right? So you do not have that continuous memory available with you. So if you don't have that continuous block of memory available with you, so in that case the array allocation will fail, because array will always require a continuous block of memory, right? So to solve that problem, we have yet another data structure called a linked list. So what does linked list do? Linked list stores the data something like this. So for every element it will store two things. First is the value. So the first is the value, that is 2, and the second is the pointer to a next node. Pointer to a next node means the location of the next node, right? So for example, let's consider this linked list. We denote it like this: 2 3 4 5, 2 3 4 5 and 6. We denote the linked list like this. Now here what happens is, let's say 2 is in location 1000. 3 does not need to be in 1004. 3 can be at 2000. 4 can be at 1050. 5 can be at 3000. 6 can be at 500. They can be anywhere, right? They can be anywhere. Now, how is this information stored? Basically, instead of a single integer, it will store two values. First is the integer that is stored there, that is 2, and second is the location of the next node, or a pointer to the next node, what we say. So 2000. So after 2, the next element will be stored at location 2000. So from 2000, we know that at 2000, what will be there? At location 2000, it will be 3, and with the next node, that is 1050. So when we want to go to the next node, we'll directly go to location 2000 and we will end up in this node, right? So this is how a linked list is stored, right? So now there are two advantages that you, or two problems for the arrays that you have solved here. The two problems that we discussed, you have already solved those two problems. How? Just think about it. First is, now you do not need a continuous block of memory, right? So even if you don't have a continuous block of memory, you can store it as a linked list and they will take up the spaces that is available. The second way that you have advantaged out of this is deletion of an element. Now if you just delete 4, you don't have to move 5 by one place. Rather what you have to do is, you just have to tell that the next of 3 is the address of 5. So the next of 3 is 5, that is 3000. So when you initially 3 was at pointing to location, let's say 1050, so you just erase this and replace this with the location of 5, that is 3000, right? So you don't have to move all the elements. So this has actually improved the efficiency of deletion as well. So like that, there are many other data structures. There are multiple variants of trees that are available, like trie is available. There are red black trees, there are binary search trees, and lots of them. There is segment trees as well. And many other like there are trips and many other things, right? So there are many data structures that are available, and each data structure has some advantage, right? So whenever you are learning about a data structure, just understand what are the various problem it solves, and if you have a question, see if your data structure meets those problems it is solving with the criteria of the question. and then you can choose the perfect data structure for your problem, right? So that's about data structures. Now let's come back to algorithms. What is an algorithm? Algorithm is a concept, right? Algorithm is how you solve a problem, right? How you solve a problem, that is basically algorithm. For example, let's say you have a set of let's take an example. Let's say 5 1 2 3. You have an array like this, right? You have an array of elements or list of elements like this. You want to sort it. What do we mean by sorting? Sorting means arranging them in ascending or descending order, or any other order in per se, right? So 1 2 3 5. So if you sort it in ascending order, that is, you arrange the elements in ascending order, 5 1 2 3 will be changed to 1 2 3 5. Now to convert 5 1 2 3, that is to sort 5 1 2 3, there are multiple sorting algorithm available, right? There are multiple sorting algorithms available. For example, you might have already, like if you had computer science in 11 12, you might have heard about insertion sort. You might have heard about selection sort, right? You might have heard about bubble sort. Apart from that, if you have some like DSA experience, you might have heard about things like merge sort. You might have heard about quick sort, right? You might have heard about radic sort and these things, bucket sort as well. So there are multiple. So these are all algorithms. Algorithms means how you are sorting. So these are all sorting algorithms. So they basically tell you how would you go about sorting the array, right? This will define how would you go about sorting the array. For example, insertion sort would find the next insertion point of the next element, right? Selection sort would always bring the smaller element to the front for the remaining part of the array, right? So something like that. Each of them defines the way. So an algorithm basically defines the way how you go about solving a problem. Now there are multiple algorithms. Now here only, if you see, for sorting only, there are multiple algorithms, right? There are multiple algorithms just for sorting an array. Which one should you use? That's the important question, right? Which algorithm should I use? That is where a very important terminology that comes in, that is complexity analysis. Complexity analysis. What is complexity analysis? Complexity analysis helps you to compare the performance of different data structures and algorithms. For example, when you want to sort an array, to understand which algorithm should you use to sort an array, you will do a performance analysis between all the algorithms. Which one is performing better? You use complexity analysis to decide which one is performing better, and then you use that algorithm, right? So that's basically what complexity analysis is. And in the remaining part of the session, we'll mostly be focused around complexity analysis, right? How do we analyze complexity? How do we compare which algorithm is better, which data structure is better, right? And which is suiting our needs. So that's what we'll focus on. Okay. Do you have any questions till now? Anyone has any questions till now? I'll take a pause here if anyone has any questions till now. Which algorithm is used when we sort an array by writing sort? Okay. So if you are familiar with C++, there is an inbuilt method called sort. You pass in the array like this, arr plus n, right? So this uses the quick sort algorithm, right? This will use the quick sort algorithm. Okay. But we'll definitely will not discuss about merge sort, quick sort, or any sorting algorithm today. Our main purpose will be to understand how do we compare between two algorithms or between two data structures, which one is better, right? Because we need some comparison, right? And just saying it out, when you solve a problem, right? Like when you sit for an interview, let's say you are sitting for an interview, or you are doing competitive programming, you are sitting for a contest, wherever you are solving a DSA question, it's not about just solving the question, right? To solve a question, there can be 10 ways you can solve a question, right? There can be 10 ways you can solve a question. For example, sorting, you can use any sorting algorithm to sort the array. But what is also important is how good your performance is. The algorithm that you're using, how good the performance of the algorithm is, and how better it is performing, right? So that is very important when you are actually sitting for a contest, because there will be something called constraints that will be given to you, and you have to write, that is time constraint, right? That your code cannot take more than this much time to run, right? And you have to use the best algorithm possible, or use the best data structure possible, and make it run in that amount of time, right? So that is why complexity analysis is very important, because without complexity analysis you cannot solve any problem, because you can always write code, you can always solve any problem, right? If you are good at writing code, you can solve any problem, but you have to learn how to solve problem optimally, because that is what people want, right? Solving problems optimally. So that's where complexity analysis comes in. All right. uh, okay, I'm assuming I don't see any questions on the chat, so I'm assuming everything is clear, but maybe I'll take a minute and ask you guys again, like if you have any questions, please write them in the chat so that I can try to discuss them as well. If you have any doubts till now, we'll not get into details about any of the things that I've talked about. We'll only get into details about complexity analysis. How do we, because again, like those things will come in later, right? If I give all the information right now, it will be too much to take in, and we cannot complete it within 1 hour, right? So definitely, I cannot give every information. You have to learn that gradually, but for now, today we'll be trying to learn as much as possible about complexity analysis. All right. Yash has said nope. So I believe no one has any questions, and Yash is taking the lead on this. All right. Okay, let's talk about complexity analysis, right? So again, like we have understood the idea, right? We have understood the idea about why do we need complexity analysis to compare between various data structures or algorithms that we can use to solve a problem, and we'll try to use the best possible algorithm, right? So okay, so all right. So let's consider a problem, right? Let's consider a problem and take a real life example, right? Sorting is definitely one of them, but let's take a better example. So let's say you are given an array of elements, right? You are given an array of elements 2, 1, 3, 5, 3, 6, 4. And you are given a number k. K is equals to, let's say, 5. You have to tell how many pairs of elements from this array will give you a sum of k. So how many pairs of elements from this array will give you a sum of k? Just by looking at it, what do we get? It is 2 plus 3 will be 5. So 2, 3 is a pair. 5 cannot be paired with anything. This 2 and 3 again can be paired, right? So 2, 3 is another pair. First pair is 2, 3, this one. Second pair is 2, 3, this one. Another is 1 plus 4 is also 5. So 1, 4. So there are 3 pairs that are giving me a sum of 5, right? There are 3 pairs that are giving me a sum of 5. 5. So that means we have to output 3. Now, how do we solve this problem? A very easy way to solve this problem is you try to fix both the numbers and see if their sum is equals to 5. If it is equals to 5, you just do count plus plus, right? So the algorithm will be something like this. Initially we'll have count equals to 0. Again, I'm assuming that you already are familiar with looping statements and conditional statements, but in case you are not, you have to read about them definitely, and as it is very important to know about these things, right? So for you run a loop for fixing the first element, right? For I equals to 0, I less than n, I plus plus. And inside that you run another loop to fix the second element. So j equals to I plus 1, j less than n, j plus plus. Right? And here if you check, if a of I plus a of j, if a of I plus a of j is equals to k, then you do count plus plus. Right? So this is one way to solve the problem. You run 2 loops. In the first loop, you fix the first element. In the second loop, you fix the second element, and you compare like if a of I plus a of j is equals to k, you do count plus plus, right? Now this is one way to solve the problem, right? This is one way to solve the problem. There is another way to solve the problem using some technique called hashing. I will not discuss, or maybe I'll discuss it later on how do we solve the problem using hashing. But there is a technique called hashing that you can use to solve the problem, right? Now, which one should you use? Should you use this one or should you use this one? That's the question, right? Which one should you use, this algorithm or this algorithm, for solving this question? That is where complexity analysis will come into picture, right? So you have to compare how well this algorithm performs versus how well this algorithm performs. Now, how do you compare? What is the metrics that you use to compare between algorithms or data structures? There are two metrics that you use, or let me just undo the changes. Yes, we'll come back to this later, but let's go to a separate screen. There are two metrics that we use to compare between algorithms and data structures. The first metric is time complexity. What is time complexity? What is the amount of time it will take for your algorithm to run, right? Amount of time it will take your algorithm to run with increasing, or how the amount of time complexity is what? How the amount of time taken for the algorithm to run, differs on changing input, right? How the amount of time taken for the algorithm to run differs on changing input. What do we mean by this? Let's say your algorithm, let's say for the array of size n equals to 5, your algorithm takes, let's say, 10 seconds. For n equals to, let's say, 6, or yeah, let's say for n equals to 10, it will take 100 seconds. So you see that there is kind of an exponential growth, or there's a n square growth on t square growth on the, like, based on size, there is a t square growth on the time complexity, right? So this is how, like, with increasing input size, how your algorithm, how much algorithm that does your like how much time does your algorithm take to run, that is called time complexity, right? So because, see, you will never, like, let's consider sorting of an array, right? You will never sort an array of size 5, you will, because that will take very little amount of time. But what you care about is how much time does it take when you sort an array of size 10 to the power 5 elements. When there are 10 to the power 5 elements, how much time does it take? Or when there are 10 to the power 6 elements, how much time does it take? That is what you care about. You do not care about how much time does it take to sort 5 elements, right? It should be very fast. So when n increases reasonably, how well the algorithm performs or how worse the algorithm performs, that is what time complexity gives us, right? The second thing is space complexity. Space complexity is basically nothing but the amount of storage required, the amount of memory required for your problem to be solved. The amount of memory storage required for your problem to be solved, right? So let's say you are creating an array of and storing n elements, right? So you will be needing n space for n elements. Let's say you are storing elements 2 times, so you will need something around 2n space or something like that. So that is like amount of storage that you need for the problem to be solved. That is called the space complexity, right? So time complexity and space complexity, these are the two metrics that will use to judge whether an algorithm or a data structure is better or it is not better for our use case, right? So that's basically these are the two metrics that we will use. Now there are multiple notations, right? There are multiple notations like this: big O notation, big theta notation, like upper bound, lower bound, right? So basically I'll just quickly like give you a brief understanding about what of these, but what is essentially important is the upper bound, right? Because, like, whenever we compare between algorithms, we always use upper bound or a big O notation, right? We always use the big O notation to compare between algorithms. But just to give an idea about what they are, so let's say what is a lower bound, right? Lower bound means that, let's say, there is a function like this, right? There is a function like this, and this is your function. So see, after some n, this is your function, right? This is f and this is g. There are two functions f and g. This is how the graph looks like. You do not care about this part, right? What you care about is the growth eventually. Now if you see after this point, let's call this n naught, right? After this point n equals to n naught, fn will always be greater than equal to gn, or some constant into gn. Fn will always be greater than equal to some constant into gn. In that case, gn is said to be the lower bound of fn, right? Gn is said to be the lower bound of fn, or this is called the omega, I believe. So fn is said to be omega of gn. That is, gn is the lower bound of fn, right? So that means after some point n equals to n naught, fn will always be more than gn, or some c into gn. So that is called the lower bound. That is, fn is always performing worse. Fn can never be better than gn. Fn is always worse than gn. That is what we are telling, right? Fn means the time, right? The time taken to run. So that is basically the lower bound. Next we come into something called upper bound, which is very important. Upper bound is something that we use. So upper bound is called order, o, big O notation, right? So let's say we have some function g, something like this. Okay, and this is f. So if you see initially, f is worse. F is worse initially, right? F is taking more time. But after some n equals to n naught, fn is always less than equal to some c into gn, where c is greater than 0 and n naught is greater than equal to 0, right? After some n equals to n naught, fn is always less than equal to c into gn. That means fn will always be less than gn, or the time taken. For this case, fn is denoting the time taken, right? Fn is denoting the time taken. So this is time series graph, right? Time versus input size. So the input size versus time graph, this is denoted by fn and gn. We see that fn is always less than gn. That is, the time taken for running this is always better than the time taken for running gn, this algorithm, right? So definitely fn is the better algorithm than gn, right? So fn is said to be order of gn. This is called upper bound. That is, we know that the algorithm will not be worse than this algorithm. Our algorithm, that is fn, will not be worse than the another algorithm gn. So we tell fn is order of gn, right? So this is upper bound or big O notation, and this is what we will use to compare between algorithms, right? How do we find this? That is a different question that will come into in some time, but this is the formal definition, right? And coming to the third notation, that is strict bound. Strict bound means that it is strictly bound by gn, right? So let's say there is some gn like this, something like this, right? This is c1 into gn, and let's call it this is c2 into gn. So fn is greater than, so fn is greater than equal to some c1 into gn, c2 into gn, but fn is less than equal to some c1 into gn. That is, fn is tightly bounded by gn. Fn is tightly bounded by gn, so this is called the tight bound, right? So fn is called the theta of gn. Fn is called theta of gn, that is the tight bound. That is, it is tightly bounded in both ends, right? It is not better than gn, it is not worse than gn as well, right? So fn is tightly bounded, although it might seem that tight bound is a better way to estimate, but again, like computing tight bound is a bit difficult. So that's why we generally go with order complexity, order analysis, right? So we just compare the upper bound, that our algorithm is not worse than this, and then check that whether it is a good enough algorithm, or we compare between two algorithms like that. So this is true for not only time but space as well. Just convert this time into a space graph and the same logic will apply, right? So that is how we compare the time and space complexity using order analysis, right? What is order analysis again? That our algorithm is not worse than some other algorithm. So our algorithm fn is said to be order of gn. Let me just formally describe it in words as well, so that it's easier for you to understand. Fn is said to be order of gn if for all n greater than equal to some n naught, if for rather if uh, let's call it something like this, if there exists some c greater than 0 and n naught such that for all n greater than equal to n naught, fn is less than equal to c into gn, right? So for all n greater than n naught, fn will be less than equal to cgn. That is, after some time, fn should be less than c into gn. This is c into gn. This is fn. Fn should be always less than c into gn after some time, right? So it will always continue to be less. So that is the definition of order analysis, right? So that's okay. I'll take a pause here as well. I know this might be a lot of information for many of you, and this might be a very useless information for many of you as well. But again, I'm assuming we have some beginners in this class as well, so for that I'm teaching this. But I'll stop right now for some time to ask any questions. If you have any questions, if you have any doubts, I'll be happy to clear them out. Let me know if anyone has any questions or any doubts. I'll be happy to clear them out. Any questions, any doubts on any of them? It might be a lot of information, but again, those are mostly terminologies that I've talked about. It's okay if you don't remember them. That's totally fine. What you should remember is how to compute order analysis, right? In which context are we does this? That's a very good question, right? That's basically whenever I write fn, gn, these things, right? These are basically time functions or space functions, right? So basically, let's say fn, we write fn is equals to n squared. That means that the time taken will be increasing proportional to n squared, right? So as n increases, the time taken increases by the factor of n squared. So basically a relation between how much time fn, let's say fn is called that for the time analysis. So this is like time taken to run the algorithm for an array of size n will be n squared. Let's say we say this. So that means time taken to run this will be approximately in the order of n squared, right? Quick revision. Yes, I'll be giving you revision on time complexity. I'll be discussing about how do we compute time complexity and these things, right? Now, this brings us to actually very important question, right? This brings us to an important question. How do we understand if the algorithm is good enough? Let's say you formulated an algorithm, right? You formulated an algorithm. How do you understand if your algorithm is good enough, right? So for that reason, what you should do is you have a parameter that is given to you when you are given a problem statement, right? You have a parameter that is given to you that is called the constraint section, constraints and time limit. These are the two sections that are available, and these are very important sections of any problem statement. So whenever you see a problem statement, you will definitely find these two sections, constraints and time limit. Ideally, in generally, we do not see the time limit section because the time limit is generally around 1 second to 2 seconds, maximum 3 seconds, right? 3-4 seconds. So the time limit is generally in this order, 1 second to 2 second to 3 seconds, something like that. So we generally ignore this time limit, but again, that gives a lot of information, right? Constraints is what is the most important section, and we must look into that. So to understand if your algorithm is good enough for the problem, what you should do is, so this is just an estimate, this is just something that I have seen till now, is 10 to the power 8 operations. If you have around 10 to the power 8 operations, that can be done in around 2 seconds of time. So 10 to the power 8 operations, again, it depends on the operation that you are doing. Definitely division will take more time than just addition, right? So it depends on the operation that you are doing, but 10 to the power 8 operations generally take around 2 seconds of time, right? So let's say if you are given n equals to 1000, what is the algorithm that you can use? Here you can use any n square algorithm. See, n squared is how much? 1000 squared. that is 10 to the power 6. 10 to the power 6 is less than 10 to the power 8, so you are happy about this algorithm. You can use this algorithm. But let's say n is equals to 10 to the power 5. 10 to the power 5, right? N is equals to 10 to the power 5. In that case, can you use a n square algorithm? Just think about this. 10 to the power 5 squared, that is 10 to the power 10. 10 to the power 10 is much larger than 10 to the power 8. So you cannot use a n square algorithm for 10 to the power 5. If you have 2 seconds of running time, right? Generally, it's around 2-3 seconds only that is given to you. So you have to be very careful about the constraints and the time limit part. And this is how your constraints affect, right? This is what, like, fn, let's say fn is n square, that is your time taken. Your time complexity is this, given by this expression, right? Fn equals to n square. That means if you have n equals to 1000, n maximum and possible is 1000, then fn equals to n square will take around 10 to the power 6, like it will take around 10 to the power 6 operations. So that will take around, you can use this to calculate, like 2 second by 10 to the power 6, 10 to the power 8, that is 10 squared, right? 2 second by 100, that much amount of seconds, although that might be a bit approximate, but again, like it will come about near about that number, right? So that is how you use the constraint to understand if your algorithm is good or your algorithm is bad. Okay, so that's how you should ideally do. But again, like this 10 to the power 8 is a number that I have seen till now, and it has worked fine for me till now. So again, like you can definitely try researching on your end and see which one is better. But again, like you will end up with a number that is close to 10 to the power 8 only, right? So generally the idea will be always write an algorithm that's complex, whose complexity is within 10 to the power 7 to 10 to the power 8. As simple as that. The complexity should be within 10 to the power 7 to 10 to the power 8, both for space and time. Always try to find out an algorithm like that. Okay, that brings us, how do we, next question, how are we telling fn equals to n square, or fn equals to, let's say, n cube or something like that, fn equals to 2 to the power n? How are we exactly saying this? This is done by finding the big O notation, right? Finding the order analysis of, like, order of fn is equals to n squared, that is what, or fn is order of n squared, that is what we say, right? So let's understand this. Let's understand this a bit. How do we do this? Let's take an example to understand this. So for, let's say we have a loop like this. In fact, let's go to the first example. For I equals to 0, let's take this example. For I equals to 0, I less than n, I plus plus. For j equals to I plus 1, j less than n, j plus plus. So you have two loops that is running, right? And what is the input size? The input size is n, right? The array size is n, that is the input size. So how does your algorithm, how does the time complexity differ with respect to n? That will differ with the number of computations that you're doing. So you are running two loops, right? So for the first, for I equals to 0, how many times the second loop runs in? The second loop will, and these everything, this if statement and count plus plus, we consider these as constant complexities, like order of one complexity, right? These are constant operations, they will not take a lot of time. But what will take a lot of time are the looping statements. So we always use the looping statements to determine the complexity. So for I equals to 0, how much will the interior loop run? It will run for n steps, like j equals to 1 to n, so it will run for n steps. I equals to 1, it will run for n minus 1 step, because j equals to 2 to n. I equals to 2, it will run for n minus 2 steps. Like that, some I equals to k, it will run up to n minus k steps. And finally, I equals to n, it will run for n minus 1 or n, it will run for 0 steps, right? So the total number of computations, that you're doing is n plus n minus 1 plus n minus 2, like that, up to plus 1. And you might already know the sum of this. This is the sum of first n natural numbers, so it will be n into n plus 1 by 2. N into n plus 1 by 2, that is n squared plus n by 2. N squared plus n by 2. Now this brings us to the first rule of complexity analysis. Let's say fn is order of some gn plus hn, and we know that gn is a dominating term. So fn is the order of some gn plus hn, and we know Gn is dominating term. Gn is always greater than equal to Hn. In this case, we will write Fn as order of Gn. So Fn is as, we'll write Fn as order of Gn, which is the dominating term, right? So in this case, we see our time Fn is order of n square plus n by 2. So here this is the first Gn, n square, second Gn is n. So we'll write it as order of n square. First of all, we'll write it as order of n square by 2. So what we have reduced this to? Fn is equals to order of n squared by 2. And we have used the first rule that we will always use the dominating term, right? So Fn is equals to order of Gn plus Hn. So it will be order is equals to order of Gn when Gn is greater than equal to Hn. We'll always use the dominating term. This is after the first step. The second step that we'll use is we'll get rid of this 2 as well. Why? Because we'll say that Fn is order of some C into Gn. Any constant term into Gn is same as Fn is order of Gn. Fn is C into Gn is same as Fn is of the order of Gn, right? So here that's why, so if you see again for this, Fn is order of half, that is some constant, into n square. N square is Gn, right? So we'll write Fn is order of n square. So finally we come to the complexity analysis, that our algorithm that we had written is order of n square. So the algorithm that we have written here, the time complexity, again the time complexity for this. So the time complexity for this algorithm is order of n square. The time complexity for this algorithm is order of n squared. Is this clear with everyone? Is this clear with everyone? The time complexity for this algorithm is order of n squared. Yes. So we have computed the time complexity of the first algorithm that we had, right? We have computed the first algorithm, and then we'll later on see the second algorithm as well, right? We'll later on see the second algorithm as well. But yeah, like this is how we compare, right? Again, similarly, we'll compare the time complexity for the second algorithm, and with hashing it comes out to be order of n, and we'll see that clearly order of n is better than order of n squared, right? So we will tell that hashing algorithm is better than this algorithm. Now that this is the time complexity that we have computed, what is the space complexity, right? What is the amount of additional space that you are using to run this algorithm? Are you using any additional space? You are using a count variable. You are using I and j iteration loops. Array is already given to you. So with respect to additional space, you do not use any additional space. So the space complexity will be order of 1. The space complexity for this algorithm will be order of 1. For hashing, the space complexity becomes order of n, right? So the space complexity for this algorithm is order of 1. For hashing, it is order of n. So we kind of do a trade-off between time and space, and we say that hashing is the better algorithm because it is giving order of n time and order of n space, which we are okay with. But this is order of n squared. So when n is equals to 10 to the power 5, this algorithm will not work, right? So that's why this is how we do the two comparisons. This is how we compare between algorithms. All right, so let's actually look into a few more examples, and let's use these properties only, right? So let's say we have something like this. Fn is the order of, you will tell me a question for you. Fn is order of 2 to the power n plus 3 to the power n plus n squared plus n cube plus 4n to the power 5 by 5 plus n. What is, how can you reduce this complexity? How can you write the final order analysis for this? How can you write the final order analysis? What is the final Fn complexity? How do you write the complexity of Fn? Fn is order of what? This is the expression that you end up at, let's say. Fn is order of what? And we have already discussed the two important things that will be needed here, right? Fn is order of what? Can anyone tell? Okay, n to the power 5 by 5. One Hitanshi is saying n to the power 5. Rohan is saying 3 to the power n. N to the power 5. Okay, the answer to this will be 3 to the power n. 3 to the power n, right? Why 3 to the power n? It's just 3 to the power n. This is n to the power 5. This is much worse. Why? Because this is the exponential complexity. Exponential. The growth is exponential. If you look into the curve, exponential complexity grows, like the growth of exponential complexity is always more, right? So just take an example, right? Let's take an example of 3 to the power 10 and 10 to the power 5. Maybe 3 to the power 10 will be better here, but just assume 3 to the power 10 to the power 5 and 10 to the power 5 to the power 5. So in this, definitely this will be much worse than this, right? So the growth generally exponential will come at the top. I think factorial should come at the top. Not sure if factorial or exponential. That exponential or factorial, right? Let's keep both of them. Exponential or factorial will come at the top. That is n factorial, something like that. After that comes the polynomial. So exponential and factorial examples will be 2 to the power n, 3 to the power n, n to the power m, n factorial, and these things, right? Polynomial example will be n squared, n cube, n to the power 5, n, these things. And after them comes the other parts. Also, these are also polynomial, like log n, square root of n, and these things. After then comes the constants. That is order of 1 and something like this, right? So this will come first, the exponential and the factorial complexities, then the polynomial, then the constant, right? So in our case, as there was 3 to the power n, definitely 3 to the power n will be better than 2 to the power n. So 3 to the power n will be the leading term. So that's why it will be order of 3 to the power n, right? Let's take another example. Fn, let's say, is order of n plus n log n plus n square root of n plus log n. What is the complexity for this? Fn is n plus n log n plus n square root of n plus log n. What will be the complexity for this? Can anyone tell what will be the complexity for this? That is, Fn is order of what? Fn is order of what? N log n. Okay, Atif is saying n log n. Anything else? N root n. Vihan and Hitansha Singh n root n. Okay, n root n has 2 votes. Okay, Shivanki Singh order of n. N log n. Okay, the answer will be n root n, right? N root n. Why? Because again, between the polynomial complexities as well, there will be order. The order will be n squared is at the top. After that, definitely n cube, n to the power 4, they will come. But up to n square only will speak. So n squared. After then there will be n root n. After then there will be n log n. After then there will be n. Then there will be root n. then there will be log n, then there will be order of 1. So this is the order that will follow. Log n, root n is more greater than log n. Root n will always be greater than log n, right? Root n will always be greater than log n. So just consider like 100, right? Root 100 will be 10. And with respect to log of 100, it will be around 2, 4, 8, 16, 32, 64, 107. It will be approximately 7. So this is the difference, right? Again, it becomes significant, like 10 to the power 5. Root of 10 to the power or 10 to the power 6, it will be approximately, or 10 to the power 9. 10 to the power 9 log will be approximately 32, whereas 10 to the power 9 root will be 10 to the power 4 approximately, 4.5. 10 to the power 4.5. Right. So root is definitely greater than log. So this will be the order. All right. So just remember these things. Again, like these are very intuitive and very easy to understand, because log is definitely better than like what's log is lesser than root, definitely. So again, like very intuitive things, right? Okay, so as we are almost out of time, I'll actually discuss a very good example with you, and this is kind of my personal favorite example whenever I teach whenever I teach complexity analysis, right? So what did we talk about? We talked about like whenever we have two loops, generally when we have two loops, right? When we have two loops like I equals to 0, I less than n, I plus plus. Let's say inside this there is another loop for j equals to 0, j less than m, j plus plus. Whenever we have two loops like this, two nested loops, we generally just write the complexity as n into m, which makes sense. For this, it is n into m, right? We just multiply the two things. But why does it become n into m? If you think about it, I equals to 0, the inner loop will run for m times. I equals to 1, again it will run for m times. Like that, I equals to n, it will again run for m times. So total number of times it will be plus plus like this. So it will be n times m. That's why we have this, right? Now I'll give you another example, and you have to tell me what is the complexity for this. For I equals to, let's say, 1, I less than n, I plus plus. For j equals to I, j less than n, j plus equals to I. Can anyone tell what is the complexity for this? And inside this, you do something. But can anyone tell what will be the complexity for this? I equals to 1, I less than n, I plus plus. For j equals to 1, j less than n, j plus equals to I. What will be the complexity for this? Hitanshi is saying order of n. That's interesting. Anyone else? यार n तो नहीं होगा, like n के अंदर भी एक loop है, so it will definitely be more than n. N squared. Atif is saying n squared. Any other takers? Ayan is also saying n squared. Okay. Yash is also saying n squared. Okay, n squared has a lot of votes. Any other crazy ideas? Tanisha is also saying n squared. Okay. Nothing crazy? Like I thought you will be like giving some random crazy numbers as well. Okay. Shivank is saying n to the power n. Okay, Shivank is out of this league only. He's n to the power n. All right. So you are dealing with polynomial. Shivank is like polynomial mein nahi rehna, we'll have to go to exponential. Chalo, sahi hai. Vihan is saying n root n. Okay, that's a new one. N root n. Others are saying n square. Okay, let's end the vote here, right? So there are multiple takers, but let's understand this. What is the actual complexity? Okay, one important thing, whenever you have two nested loops, that's a very bad thing that we do. Whenever we have two nested loops, we'll just multiply n into n, right? That's something that we should not do. We should do a proper analysis, right? First, see, for I equals to 1, how many times is the loop running? j loop is running for n times, because it is j equals to 1, j less than n, j plus equals to 1, that is j plus plus. It is running n times. For I equals to 2, how many times the j loop is running? J equals to 2, j less than n, j plus equals to 2. So you are jumping by steps of 2. So it will be running n by 2 times, right? Because 2, 4, 6, 8, like that it will go. So n by 2 times. I equals to 3, j equals to 3, j less than n, j plus equals to 3. So it is making jumps of 3. So it will be running n by 3 times. Like that, I equals to k, it will run n by k times. And finally, I equals to n, it will run 1 time. Right? So what do we have? Okay, Atif is saying n log n now. N. So what do we have? N plus n by 2 plus n by 3 plus n by 4, like that, up to n by n, that is 1. Let's take this n out common. N into 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by n. This is what we have. Now we have n into something. N into something, right? 1 by 2 plus 1 by 3 plus 1 by 2. So let's call this gn, right? So we have n into gn. Let's compute the complexity of gn, right? So gn is what? Let's write it down here. Gn is what? Gn is 1 plus 1 by 2 plus 1 by 3 plus 1 by n, right? What did we talk about? Order analysis. Order analysis means that our gn should be not worse than hn. We will say gn is order of hn if gn is not worse than hn after some n naught. After some time, gn should never be worse than hn. That is order analysis. We cannot compute this thing, right? But what we can do is, we can compute with this 1 plus 1 by 2, 1 plus 1 by 2 plus 1 by 2 plus 1 by 4 plus 1 by 4. So what we are doing is, we are rounding down each of the elements to the nearest lower power of 2, right? Like 3 is rounded down to 1 by 2. So 3 is greater than 2, or 1 by 3 is less than 1 by 2. 3 is greater than 2, 1 by 3 is less than 1 by 2. Similarly, 5 is rounded down to 4. Here there is 1 by 4 plus 1 by 5. 1 by 5 is rounded down to 1 by 4. So 5 is greater than 4, or 1 by 5 is less than 1 by 4. 1 by 4, 6 is also 1 by 4, 7 is also 1 by 4. After that, 8 will be 1 by 8, 9 will be 1 by 8, and like that it will continue. Right? Okay. Now let's come to this. Let's understand this. We know that our this thing will definitely be less than this thing, because individual terms are less, right? 1 by 3 is less than 1 by 2. 1 by 5 is less than 1 by 4. So our gn is less than this thing. So it is less than 1 plus 1 by 2, that is 2 into 1 by 2, plus 4 into 1 by 4, plus 8 into 1 by 8, like that it comes up, like that, plus k into some k into 1 by k. That is 1 plus 1 plus 1, 1 up to k times. Up to k times, we have 1. So our gn is less than 1 plus 1 plus 1 up to k times. What is the value of k? What are we rounding down it to? Nearest power of 2. So 2 to the power k should be less than equal to n, or k is equals to log 2n. So we are summing up 1 log n times. So gn is less than log n, log 2n, right? So that brings us, it is less than n into log 2n. Our fn, let's call this fn, time complexity. So the order analysis will be fn is order of n log n. Fn is order of n log n. Is this clear with everyone? Fn is order of n log n. So the correct answer will be n log n. Is this clear with everyone? Okay, so yep, that's about time complexity. Like whenever you are comparing between algorithms, you have to like do a asymptotic analysis of the time complexity and the space complexity. Then you will do a trade-off like which one is better, which one is worse, right? And in many cases, in most of the cases, you have to give up space complexity. Like one algorithm will run in order of one space, but will take more time, n squared time. Another algorithm will take order of n space and order of n time. So the second algorithm is better because we're giving off space. Yes, you are taking order of n space, but order of n space is fine. Order of n time is also fine. So that is a better algorithm, right? So that's about complexity analysis. And like let me know if you have any doubts. I'll spend the next 1 minute like taking doubts, and yep, that's the end of the session. So thank you guys for hearing in, and yeah, let me know if you have any doubts, like whatever has been taught to you today. Let me know if you have any doubts. Okay. I'll stop sharing my screen. All right. Thanks for joining in, and Mansi is also here.
Thank you so much, sir, for this knowledgeable session today. Your depth of understanding of DSA and your ability to present the topic in such an interesting way produced one of the most memorable sessions. We appreciate your efforts and plan to learn more. Thank you again for your time.
Thank you. Bye, everyone.
So, guys, right now we will be having a quiz regarding today's session. Kindly attend the quiz. Winners will be getting exciting prizes. Link is in the description box. You can check it out. Also, the link is only available for 10 minutes, so be quick with your answers. With this, I want to end this session with a quote. A good event never ends in the world. They take only a pause and keep us awaiting for the next. So keep hoping for the best and keep shining. And thank you so much for being such a wonderful audience. Also, special thanks to our sponsor Geeks for Geeks and our speakers Mr. Sandeep Jain and Mr. Soham Mukherjee. Without them, the session would not have been possible. See you all tomorrow at the same time with another insightful session. Till then, keep learning and don't forget to give the quiz. Goodbye.